Scientists have recently discovered a strange object in space, and it's unclear whether it's a star or a planet. What we do know is that it's located 1,400 light-years away, prompting us to rethink some of our understanding of the universe. To explain the dilemma, we typically distinguish stars from planets based on their mass. Stars have much more mass, which creates strong gravity that compresses them, leading to high internal temperatures that cause them to shine brightly. Planets, on the other hand, have less mass, so their gravity is weaker, and they don't generate the same high temperatures. Instead, planets shine by reflecting light from their stars, like Earth does with the Sun. This new object, however, falls into a strange category. It's considered a brown dwarf, a type of large, gaseous protostar. Brown dwarfs are typically similar to Jupiter in their atmosphere, but are much larger, 13 to 80 times the mass of Jupiter. If a brown dwarf exceeds 80 times Jupiter's mass, it starts burning regular hydrogen like a star, which is what makes stars shine. However, brown dwarfs are usually not as hot as stars, burning at around 40 degrees Fahrenheit, which is cooler than most stars. This has earned them the nickname failed stars. But this particular brown dwarf defies expectations. Its temperature reaches a scorching 1,300 degrees Fahrenheit, much hotter than most brown dwarfs, and even hotter than the Sun's surface temperature, which is about 930 degrees Fahrenheit. What makes this brown dwarf so hot is its proximity to a white dwarf, a dense, compact remnant of a star. These two objects are so close that the brown dwarf orbits the white dwarf every 2.3 hours. This tight relationship means that one side of the brown dwarf is always facing the white dwarf, while the other side remains in perpetual darkness. The side facing the white dwarf becomes superheated, while the night side remains at a more typical brown dwarf temperature. The intense temperature causes the molecules in the brown dwarf's atmosphere to break apart into individual atoms. As the dwarf's molecules disintegrate, it's slowly fading away. If you think this brown dwarf is hot, consider the star Eta Carinae, located 7,500 light-years away. It belongs to a group of stars known as luminous blue variables. This star has gone through dramatic changes. Once a medium bright star, it became one of the brightest in the sky during an event known as the Great Eruption. During this eruption, it released as much energy as a supernova, remaining extremely bright for several years. The star is now dimmer, but still alive, surrounded by a nebula made of gas and dust from the eruption. Eta Carinae is a binary star system, with two stars orbiting each other. The more massive star, 100 times heavier than the Sun, is expected to eventually explode as a supernova, but not for several thousand years. And speaking of supernovas, they represent the hottest events in the universe. Supernovas occur when a star that is 8 to 40 times the mass of the Sun can no longer produce enough energy to counteract its own gravity, causing the core to collapse. The temperatures during a supernova can reach up to 6,000 times higher than the core of the Sun. On Earth, humans have created incredibly high temperatures too. In Switzerland, scientists created a subatomic soup called quark gluon plasma, reaching temperatures 250,000 times hotter than the Sun's core. This experiment was aimed at recreating the conditions that existed shortly after the Big Bang. Finally, in theory, temperatures can go even higher. There's a concept known as the Planck temperature, which is so high that it's beyond our comprehension. A supernova's heat is nothing compared to this extreme, and we can only speculate about how matter behaves at these temperatures. And that wraps up this incredible journey through the hottest things in the universe.